Good morning. Hello, everybody. Welcome, welcome. Welcome to Wednesday, second class of science. Hello. Are you guys typing? Hello. Hi. I mean, no, hi. Thank you. There we go. Good morning. I'm like, no one's talking to me. What's going on there? Awesome. Hi. Okay. So we are here. We're back. Anyone have anything fun last couple of days to tell me about since Monday? First week of semester 2. Anything exciting? Got you. Oh my gosh, Jocelyn, that's exciting. I remember that. Oh my gosh. I remember how slimy my teeth felt when they came off. I did that. I'm like, oh my gosh, it was so weird. And the first thing I did, because I had crooked teeth most of my life, I have a very small mouth, believe it or not, I talk so much, but the first thing I did was I grabbed a cheese slice and I bit into it so I could see the perfect half shape of the thing, because before when I bit in it, it was all jagged and all over the place. That was one of the first things I did. It was so exciting. But yeah, that slimy feeling. Oh, you got to Skype. That's awesome, Em. That's good. So Jocelyn, I'm assuming you're very happy they're off. That's a nice feeling. Probably had it on for a couple of years, I'm thinking, eh? Good. Yeah, I know. It's so fun. Advice, if any of you guys have had braces, advice. So I have that back brace on the bottom teeth. Make sure you have that. If it ever comes off, get it put back on, because you are amazed at how much your teeth actually shift. And then wear your retainer. I wear my retainer really well, and I have my front teeth are still moving, because the retainer is like, it's not like, if you have a mouth guard or if you have a bite guard or something like that, those have like little notches where your teeth are and stuff, and so it keeps it permanently there. Your retainer is just like a gentle kind of barrier that says, yeah, we'll keep you in here. It still allows them to move around a bit. So best to do that so it doesn't move around too much, but definitely do that. So yeah, beginning of the summer, that's going to be nice. That would be a nice summer for you, Belle. That's good. I'm using my phone for my part as my laptop's having problems. Okay, thanks, KDT. For 2 years, yeah, it's a nice thing to get them off. I actually got them off for a friend's wedding, right? I got them off like a couple weeks early, because I'm like, can I please have them off before my friend's wedding, so all my pictures at least don't have braces in them. So yeah, so that's good. Awesome. You're using your phone too, Jess? Okay, not a problem. No worries. All right, so I have another Batman joke. Thought I'd do that. So I see Alyssa's in live. Hi, Alyssa. Can you just make sure you're also in Blackboard as well, please? So you can see responses and all that kind of stuff. Just make sure you're there. And I'm still don't have. Okay, perfect. Okay, so just letting you know, today is art lessons, and I believe that's 1:30. I don't know why I took that off, but and then badminton 1:30 on Friday. So yeah, a couple things going on. Before I forget, Mrs. Wood has sent you guys all a message about Experience OC. So this is something that you guys all need to be going to. And she sent you a link. You click on the link, and then you kind of go through and figure out what you want to see. So there's a deadline for it, and I should have wrote it down. I didn't write it down what the deadline was, but make sure you get your courses selected. Well, not courses, but your what you want to go visit, the classes you want to go visit by that deadline. So just a reminder, make sure you guys get that done, okay? All right, obviously our KDP and Sean are obviously sad you guys can't be there, but yeah. All right, so yeah, so that is just a reminder that you guys need to do that. I did a little faux pas yesterday. Mrs. Wood actually wanted to come in front here and talk to you guys about it at the end of yesterday's class, or Monday's class, and I had a sticky note to remind me, but it was over in the wrong spot, and I totally didn't even remember, and I'm like, oh, I forgot. So yeah, so she, that's why she sent you guys the email, because I wanted her to make sure that she got to say that. So yeah, okay, so any questions on that? I don't know a ton about it. I have to ask a lot of questions. This is my first time going to it too, so. Okay, today's plan. We're going to start just doing a little bit of review of the periodic table. We're going to be working towards some little bit different concepts than what you've learned, but we're going to start just sort of making sure we have a base understanding of some things before we move on to those. I'm going to get you guys to do a core competency assessment here in a second, and then you got a couple worksheets to do, and there's going to be a quiz next day. Not on the periodic table, where I'm not going to make you guys memorize what is number 10 on the periodic table, or 46, or what is atomic mass of this one, but it's just a general understanding, and it's going to be kind of the first little bit of what we're going to do, just so you understand how it works more than memorizing the stuff. So, okay, that's the plan. So what I want you guys to do right now is I want you to go to the Moodle site, and I want you to do a core competency assessment. So I'm just going to get out of this for a second. I'm going to show you what I want you to do. So again, this is mine, so it's going to look a little different than yours. But underneath where the airplane lab stuff was and everything like that, it says must do paper airplane lab communication core competency reflection. If you haven't done the paper airplane lab yet, then you can't do this. But this is something that I need you guys to do when you actually do the paper airplane lab. So what I need you to do, so what you're going to do is you're going to click on that link, and it's going to take you to this, and it's going to get you to assess yourself on the core competency of communication. All right, and so you fill in the required parts of it. And then these are, for the reflective part of it, these are the core competencies put into just like different lingo. And I haven't done this stuff with you guys before, but what this is in the First Nations language of our local Okanagan people. And so it kind of means to deduce something which is kind of reflective. So I actually had to get them to translate this for me when I put this in here. So these are basically the reflective pieces looking at communication. So I think about what I'm learning. I can explain about my thinking and connections. I think about how I can improve, take pride in my work, celebrate my successes. So then what I want you to do is you're going to go through and answer 1, 2, 3. And at the beginning, it says 1 means you're just beginning to emerge with that skill, 2 means you're developing, and 3 means you're proficient, meaning you're pretty good at it. So you're going to go through, everything is a must, so you have to answer every question. So do you think about what you're learning? So it's a 1, 2, or 3, and so on and so forth. And then the last question says choose one of them, okay? So what you're going to do is choose one of these 5 things that you just assessed yourself on 1, 2, or 3. So maybe you want to, and then what you're going to do is then talk about it. So it says, for example, if you chose I celebrate my successes and give yourself a 3, you need to explain with detail and elaborate why you gave yourself that value. Or you can choose another point that you gave yourself a 1 on and explain why you feel you're not demonstrating it yet. And then that's what you guys write into this spot here, okay? So people that have finished the paper airplane, I'm going to give you guys about 5 minutes. People that haven't done it, you've got 5 minutes to work on your paper airplane. Start writing some things out. You can, because you're writing a lab, so even if you haven't performed it yet, you can write out your hypothesis, your variables, your question, your materials, your procedure. If you haven't started it yet, you can start doing those things. And the people that have finished the paper airplane lab, I'll need you guys to go and do this, okay? All right, so is 3 the highest? Yes, it is. No, you don't need to put your last name, just my Caitlin's you do. Just put your last initial or something like that. Everyone else is okay. If we press submit, then will it be fully submitted and handed in, or do we? Nope, this is, yeah, once you hit submit, it's taken care of and it's done. Yeah, okay. So I'm going to give you guys 5 minutes, do that, and then we'll be back, okay? Yeah. Hi. Okay, Kaylin's back. I was like, Kaylin's gone, Kaylin's here, Kaylin's gone, he's here. So good. You're obviously having connection issues and stuff like that, so that's good. It's good that you're here. All right, so if you didn't have enough time, you can go and do it. If you have, again, not finished your homework that was due today, this morning, like obviously, then you can make sure you get that done, and then you have to do the core competency reflection after that, okay? And I know you guys have done a lot of that with Mrs. Ward, and it's not a mark thing, it's just something that we're working on, and then at the end of the year, you're gonna do your own kind of self-reflection on all of that, so. Okay. It said we needed I think once you hit submit, you're fine. I don't think you have to hand anything in. Oh, that's for me to assess it. That's for me to kind of go in and say that you've done it and stuff like that. Yeah, okay, perfect. All right, so we're gonna look at the periodic table. A chemist's most powerful tool. Yes, that's what it is. So some of you guys probably have a background knowledge on some of this, or this is a reminder, or some of you are like, oh, I have no clue. I don't remember any of that. So that's all good. That's what we're doing. Angelina, Kaylin, be good. Okay. So, atoms, so just basically, now sorry, 1 second. So guys, you should have this available with you. So that was the note sheet that I asked you guys to print off. We're not going to be quite yet taking notes, but as we go along and as I get to certain slides, there's going to be spots for you to write things and stuff like that. So if you did not print this off, so like I said last class, you need to start always going back and checking beforehand the next day that you have everything that you need to be prepared for this class. I'm not going to be necessarily writing notes for you guys. I'm just going to be showing you guys presentations and you're going to be taking the notes. So like with math, it was completely different. We worked together and we did it like that. It's not going to be like that for science. So what I've done is made my presentation and then made some notes and have some blanks and stuff and parts for you to fill in. Okay, so that's why I really need you guys to print them off, because trying to do this without having it is going to be a little bit difficult. Okay, so yeah, so make sure you have this ready to go. Not quite yet needing it, but we're there. We're going to get there. All right. So so this one, just a quick introduction. So atoms join together to form compounds. So an element is a pure substance made of one type of atom. Most of us know that. I think that gets taught in grade, actually I think Mrs. Kelly's doing it with the grade 4, 5, and 6s. So, so for example, oxygen is an element, and the air we breathe is O2. That's usually how it's represented. And compounds are pure substances, so you learn about how things are separated and the mixtures and all that kind of stuff, but they're made up of different atoms. So that's a little bit what makes a compound different than an element. Oxygen and hydrogen, those are both atoms or elements, and then when you put them together, it makes a compound H2O, like that. All right, so chemical change occurs when the arrangement of the atoms in the compound change to form new compounds. So you guys have probably done some chemical change, physical changes, and chemical changes is the atoms form new compounds when the chemical change is happening, energy is given or taken out or something like that. Nope, not yet. I'll try to give you a little hint. This one's a little different. I'm not going to get you to start taking notes quite yet. It'll come in a little bit, I'll tell you. The other ones are almost at the start. So, yeah, no, that's fine, Jess. Okay. All right. So that's just a picture of showing what a water molecule looks like, compound looks like. So we've got the oxygen atom and we have 2 hydrogen atoms. And we're going to learn a little bit more of why there's 2 hydrogen atoms in there. You might have touched upon it in grade 8 and 9, especially maybe 9. This one we're going to spend a little more time looking at that. And then you're going to learn about how to do those write-ups where they have numbers everywhere and stuff like that. You're going to learn how to do those. So it's going to be kind of cool that way. All right, so I'm going to send you guys off here in a sec to go and watch a couple things. So this one is the history of the periodic table, and it is roughly a 7-minute clip and it talks about where the periodic table came from. So it's always nice to have that information about how it was figured out and where they got their information from. So I'm going to get you to watch that, and the link takes you there. I'm going to open up the link here in a second on Moodle. Then on the same link, this is the only tricky part, it's not a separate link. I tried to make it a separate link, but it takes you right back to this guy, which is so weird. So, Mendeleev, he has a little section. So when you are on this site, when you click on this site, you're going to watch the video that shows up there. Then if you look over to the right, you know how they have little kind of teasers of other things you might want to see. On that is going to be one that is called The Genius of Mendeleev's Periodic Table, okay? And then I want you to watch that one, and it's roughly about 5 minutes, okay? So in total, if I'm going to give you guys about 13 minutes here, and I'm going to get you guys to watch those 2 clips, and I'm going to just go open them up here for you guys right now. All right, so that one and that one for you guys. So you might just have to refresh your Moodle and go watch. It's going to take you to the same spot, but the Mendeleev one is just on the right-hand side of that same link. Okay, so 13 minutes. I'll get you guys some time to go watch that right now. Okay, see you in a bit. Okay, hi. Hopefully that was enough time to watch those. So just a little bit of a history and what it also shows is how science is always an ever-evolving doctrine of information, facts, knowledge. So as new things get discovered, they replace old ideas. That's the fun thing about science. New things are always being figured out, discovered, and it's letting us know that things aren't always true. Like it was once believed the earth was flat, right? So it's really cool to see how things emerge. And so when someone comes up with an idea, everyone's ecstatic because they're like, oh my gosh, that's a great idea. You know, like let's make the periodic table by atomic mass. And they got it figured out, and then they start realizing, okay, this is not a perfect system, and they're starting to figure out that, you know, there needs to be something else, and there's always some brilliant person out there that's able to come up and figure out a way of solving some of those problems, which is super cool. Okay, so yeah, so that was that, and Mendeleev obviously was spearheaded into the his initial one didn't quite work, but it worked us into the system of the periodic table that we have right now. So this is just an idea of the periodic table, and there's 118 elements on here. Who knows, there might be more coming. And some of the elements, tell you the truth, when I was in school, there's more elements now than there was when I was in school. And some of the elements that they've made, they actually can only create inside of a lab and stuff like that. They're not found naturally in nature. So some of these in here that are new are those ones that have come lately, but they're on here now, and they're usually kind of later on in the numbers on the periodic table. So this is just showing the colors on here are showing, why is my mouse not showing up on the screen? Okay. Are you talking about plasma and the BEC slate? Are those the ones you're talking about, or? Okay, haven't heard about those. We can talk about that a little later, because I was just doing that, so I haven't seen anything. Okay, so there we go. I just had to be in a different way. So this is showing the periodic table, and the colors. So the green ones are all the metals, and then the ones that are in yellow are non-metals, and metalloids are the few kind of going along that are kind of the in-between sort of things. So this is showing also when you take, for example, hydrogen, it's showing what each one of these numbers represents. Obviously this is its name, and obviously that's its symbol. And then the 1.0 is an atomic mass, and then this is its number that it's given, and it goes by the atomic number, which goes by the number of protons that are in the nucleus, okay? So I just wanted to give you guys just a general picture of what that looked like, and so you can see that there is segment according to if it's metal, non-metal, or metalloid, okay? So this one ranges it when they are in their room temperature state. What are they? Are they a solid, liquid, or gas? And so this is color coding it according to that. And I'm not going to make you guys don't need to have this memorized or anything, but I just wanted to show you that there are some differences on here. So there's only a couple that are actually liquid while they're in room temperature. Most of them are solids. And so that's quite interesting that when you would have it in room temperature, some of them aren't going to all be like a solid like we're used to or something like that. So they all vary that way. So I just wanted to show you that one, okay? All right, so periodic table. So the elements are listed by their atomic numbers. So that was something that after Mendeleev found this, that was sort of a generic accepted idea that it was going to go by atomic number. And the metals are on the left, non-metals on the right, and the metalloids are in the middle. So on your sheet of paper, there is a spot to be writing that down, but that will show up also another spot. So if you go to the part on the second page where they're actually showing the graph, it kind of has some arrows where you can write in where they are. So let's show you. So this spot right here, the arrows are pointing to these big arrows right here. Not these little small ones, but these big ones right here. So this one going this way is pointing to the nonmetals. So you guys can write that in right here to the nonmetals. And then this one where the line is actually inside the arrow, that's where you can write down metals. Okay? And then the other ones we'll talk about that in a little sec. in a little bit for those. Okay, so get back to my display. All right, and then the other parts in here is talking about the names, and in the video it was talked about. So it says the rows are called the periods. So the rows are the ones that go horizontal like this. Okay, those are called periods, and all of those in there have electrons the same, in the period have electrons same general area around the nucleus. So they have the same number of shells is what that's talking about. So hopefully you learned about that in grade 9. I'm hoping. So shells are where so the nucleus is in the middle, and the shells are what's on the outside. We'll look at that in a little bit too. And it's whatever period they're in, that represents how many shells there actually are, basically orbiting around, the electrons orbiting around the nucleus and stuff like that. Nope, these are your note sheets, Belle. Yeah. So columns are the other ones. So columns are the ones that go up and down, that kind of thing. And this will help you also as well on that, the graph. So the group 1 is basically kind of column 1. That's what they call it. So it's called groups or families. So group 1 is the first one, and that's called alkali metals. So you guys can be filling that in on this chart again. So there's the little small arrow here. It's going to be hard to see. Is alkaline metals, and then number 2 is alkaline earth metals, and I can't mouse over. Yeah, so the green would be alkaline metals. So on, yeah, thanks, yeah. On your sheet, it will be the alkaline metals. The yellow, which is group 2, is the alkaline earth metals. So you can write those in. 17 is all the way on the other side. It's the last orangey looking one, peachy looking one. That is the halogens. And then the very last one, which is sort of the tealy looking color, is the noble gases. Noble gases are really cool and special. So you guys can fill in, that will fill in everything on that graph on your note sheet. I need to learn how to spell these words. Yeah, I know. So yeah, so we can go back. Actually, if you guys look at the bottom of the green one, it says alkaline metals there. So it's spelt there, it's a little small. And then below the yellow, it says alkaline earth metals. So that's there. And if I move out of the way, below the orange says halogens, and below the noble gases, it's below the green, it's kind of tealy green, it says noble gases there. So that stuff is there for you. Alkaline, L-I-N-E at the end. Yeah. So you can add those in. So those are, yes, yeah, perfect. Those are the names of how they've sort of chunked them out in the columns for you there, okay? So there we go, if I stand a little bit that way. So that's just showing you the names. So not only are they groups or families, but they have, some of those have actual names. Then we have the metals, metalloids, we have the non-metals, and then the periods talk about that. So that is a general understanding of the periodic table, and that's something I want you to make sure you understand. So I'm not going to make you memorize 74 tungsten, right? I'm not going to make you memorize that, but I want you to know that there's metals, non-metals, where the alkalines are, where the noble gases are, that kind of thing. Halogens, H-A-L-O-G-E-N-S. Yes, thank you. Perfect. That was my spelling test, right? Awesome. Okay, so if we can go back there, Magical Merle. Perfect. So there are the words again for you. So it's just showing how the columns are all named. The rows don't have names, but they represent, the number represents how many shells there are on them. Okay. So this is showing it again, just I'm pointing at them for you guys. So it's again talking about the columns. They have groups or family names. And elements within the same group have similar properties, but they have the same number of valence electrons, and that's how many are, how many rings they basically have, kind of thing. So yeah, so that's just general understanding of that. Okay. All right, and then looking at the periods. So the periods are the ones that go horizontal, go this way. So the row is called a period. And element is not, an element in the same period do not have similar properties. So that's not what it's talking about. It's talking about the number of electron shells that they have, okay? And I'm just going to go back. So valence shells, we're going to look at that in a little bit more, but the valence shell, that's the name given to the very last ring, and that tells you how many electrons are in that ring depending on what column they're at, and you guys are going to have some practice doing that. And I've given you, I don't think I've opened it up yet, but I've given you on the Moodle site my kind of sheet that shows how you can kind of figure things out quicker about how many electrons are in that last shell, that last ring. So I'll show you that in a little bit. Okay, so that's just having a little bit more of a deeper look at the periodic table, looking at what the periods mean. So the periods that go this way, the number 4 means it has 4 rings. That's basically what that means. So everything in that green one, they all have 4 rings. And then the column in the families and the groups that tells you how many electrons are in that last ring. So that's sort of the difference between the two. How we doing? What's going on? Are we good? Yeah? Excellent. Okay, so I'm going to send you guys away for about, let's do 8 minutes. No, let's do 7 minutes. We're going to do 7 minutes. I'm going to get you to watch 2 things. I was going to get you to watch 3 things, but I'll let you watch the third one on your own. It's not something, it's something if you want to watch, if you're interested in. So it's going to show up on my slide here, but I'm not going to, I'll just talk about it. So the first thing I want you to do is there's a periodic table sing-along song. And so I've opened it up for you. Don't go there yet. And it's a song about the periodic table, and it's they actually put all the elements into the song. It's really crazy. And so what I put onto Moodle is the actual lyric sheet for it, so you guys can kind of have both of them and look at them and see what they say. So that's about a 3-minute video I want you guys to watch. This one I don't want you guys to watch, but it talks about where they got their names from, because it's really weird how some of them have a name that starts with the letter B, but like gold is not G-O like you would think it would be, right? So it just kind of gives you a little bit of background information of where their names came from, but I'll get you guys to watch that in your own time if you want to do that. Good, that's awesome. So that one you're not going to have to watch. I didn't even open it up for you, so you can't even go and watch it. And then this one I want you to watch, and we're going to discuss this when we get back. So be prepared. I'm going to like start asking questions. I might pick you randomly, so even if you don't want to talk, you're not going to get away with that. I'm going to ask you some questions. So it says what's in your cell phone. So what's super cool about this one, it gives you an idea of what actual elements are in your phone that you might not actually be aware of. So it's really cool. So here are the questions that I'm going to get you to answer when we get back about the cell phone. So 1, what did you think? So what were your thoughts about the video on the cell phone? What did you find most interesting? So what was something about what you heard that we were like, wow, that was really kind of cool or interesting? And what did you find the most shocking, going, oh, really? Are you kidding? So I'm going to ask those questions and then get some of you guys to respond by volunteering or me voluntold. I'll get you guys to answer those questions. So I'll give you guys 7 minutes and watch the song and then watch the cell phone one, and then we'll talk about the cell phone when we get back. Okay, 7 minutes. See you guys in a bit. right. Hello. I had to watch all that stuff again because sometimes I plan this so early that I forget what it was about. I love that song. I love when he slows down and goes, and this is where it splits and goes off and talks about the stable noble gases and everything. And he does go fast, isn't it? Like, yes, I saw your comment. It's amazing how, I wonder how many times like he has to redo it because he gets tongue-tied and everything. So that was kind of cool. And it's also very interesting, the cell phone thing. So, oh, you're supposed to watch the phone, Galen. So the phone. So I am going to start with Bryn. What did you think about the cell phone video? What was kind of just a general thought or feeling or whatever from that about the cell phone? So what did you think about that? And then I'm going to say, what did you find most interesting, Christiana, what did you find most interesting about the cell phone video? Yeah, there would be a lot of free time to do that. So yeah. So Bryn, I thought it was interesting and I didn't know any of the facts. Good. So it was, you found, what did you think? You thought that there was some really cool things in there that you didn't know about. Perfect. And Christiana, what did you find interesting? I know there's a ton of elements in there and it's you don't even think about that. What did you find shocking? Who do I want to ask? I'm going to go down here. Sean, what did you find shocking about it? And Christiana's answering, so that the glass is one of the most rare. Yes, isn't that so interesting? Like they have some very, very rare elements that are in this glass. So that's why, you know, these things are prized and worth the money that they are. So it was interesting to know that phones contain gold and silver. Yes, $2.5 billion in 1 year. This is obviously an older video that was put into all the phones. It's crazy. I was shocked by the amount. Yeah, I know. It's crazy. And what Magical Merle and I were just talking about, how other countries, third world countries typically, are wanting our electronics because like a phone gets thrown away. Like think about if they take 5 phones, how much can they get out of that and mine and get and sell or use or whatever, right? So it's interesting what's in there, and there's a lot of elements in there that we've never heard of, and ones we obviously have. So yeah, it now makes sense why they're so expensive. Yeah, because they're putting some stuff in there. Like there's people here in Kelowna in the west side that have been stealing copper, because copper is a very valuable element, and they've been stealing that, and they've had to like put safeguards because copper is used in a lot of our wiring for I think it's in the phone lines and stuff like that, I think. Don't correct me if I'm wrong, but and they've been stealing those, so they've had to do some safeguards to try to prevent that. And so there's copper in our phones, right? So it's something that, you know, you have to just be aware of. And arsenic, I know. I saw a stat about US and the FDA has now released that, I won't get into that, but there's arsenic and some stuff that's not good. But arsenic's in a lot of things that we aren't aware of, so it's cool. Yeah, so yeah, perfect. Okay, so thank you. So I hope you guys got out of that what I wanted you to, just to realize like how important these elements are and how they use them in combination to make these amazing things. And the minds of these guys, they're just geniuses to go, let's put this one and this one, let's mix it together and see what happens, right? Like, and they figure this out and they're like, oh, that didn't work, and they add another one in, and it just blows my mind the way some people think and how they're willing to try these things. So yes, and copper, yeah, exactly, yeah. It might be just on your end, I don't think, because I'm not doing anything with my audio here. Yeah, it should be all good. Okay, so this is really cool. This is a periodic table with pictures, and it shows where an element, what you would find it in everyday life. Some of the stuff is not like everyday life, so yeah, exactly. So yeah, so what I've given you guys on the Moodle site, you can print it off if you want. It's just really a neat way of going, okay, so let's look at Nubibium, I think that's how you say it. It's in the maglev train. So those are the trains that use magnets to levitate themselves, and they're mostly in Europe right now. So that element's being used in that, right? So it's really cool. Like we know what hydrogen is and we know what oxygen and helium, but all of these other ones that we aren't aware of, it's sort of interesting to see what other objects they're actually in. So I've given you guys that to look at, and you can print that off. Yes, they are super fast. They're crazy. Okay, so your note sheets are going to technically start coming now. And so we're going to go through some of the stuff, and you guys can start writing those in, okay? So, atomic structure. So what I want you guys to do is this picture, we're going to draw a similar picture to this one here that will go where it says the atom and it's blank on your sheet. We're going to draw that in a little bit, but we're going to skip down to that first blank that's on your sheet. Okay, so it says atoms are the smallest particle of the element that retains the properties, oh, spelling mistake, of the element. Okay, so that is the smallest part that keeps the properties of that element. So most of the mass of an atom is concentrated in an extremely small, dense area that is called the nucleus. Okay, and it's positive because the only two things in there are neutrons and protons, and so neutrons are neutral, right? So the protons give it that positive charge of that. Okay. The nucleus contains protons, which have the positive charge, and neutrons, which are neutral. And then we have electrons, the negative ones, and those guys are orbiting in the shells all the way around the side. So the second one, does anyone know what those all, so the second one says the particles that make up an atom, does anyone know what they're called? When we look at electron, proton, and neutron, what are those things called? Yeah, you're writing the stuff in your notes, Katie. Yeah. Yeah, so I said that notes started. What are those three things called? They're called... Yes, thanks, Dean. Yeah, they're called subatomic particles. Excellent. Thanks, Lindy. You got that too. And Cassie, good job, guys. Yes, this is the sheet you printed out, Kate. Yeah. So, it's this sheet here, right? So this first line was the atom, and then we're just talking about this one, which is the subatomic particles. And then we wrote the three particles here. Okay, so then now you're going to work on this part here. So the symbol for proton, symbol for neutron, and symbol for electron, what their charges are. So with this one, actually I'm going to be doing that in the next slide here. So let's go back to my slides. Okay. So looking at the subatomic particles, this is looking at what their charges are, and what their symbols are, and where they're located, and what their mass is. They're right here. So proton, neutron, electron. Then I don't know what to tell you, KDP, because that's on the worksheet that I just showed. I just literally had it up on the screen. It's on that worksheet, so I don't know if you printed off something different. I don't know, but it doesn't look exactly like this, but it's the same thing that's on there. Okay. Okay. All right, so we have the proton that has a positive charge of +1. Its symbol is P with a little plus. It's located in the nucleus. We have the neutron, which has no charge. It is with an N and a 0, so it has no charge there. An electron is -1. It's negatively charged, and E to the negative. E to the what? E to the negative. Yeah. Don't worry about the mass thing. It was on this table and I just left it there. So that's looking at just a little reminder of what these particles mean. Okay. So the nucleus. The nucleus is at the center of the atom. It is composed of the protons and neutrons, and the electrons exist around it. Okay, so this is just a little bit of a picture of what an actual atom would look like with the stuff around there. You guys don't have to write down the location of the mass because that's already on your chart. So you're just writing the charge and the symbol. That's all you have to write down. My presentation also will be posted later as well, and you'll be able to look at the video from that as well too. Okay. So the big thing here is seeing how the atom actually looks. So going around in the rings around the nucleus is electrons, and they're in their orbit around that. Okay. So This one is showing you how it looks on the periodic table and what each of those numbers meant. We kind of looked at it already. So the number of protons in the nucleus is called the atomic number. So that is how that gets determined. So this 32, that means there's 32 protons in germanium. Okay, so that's what that means. In titanium, there's 22 protons. That's what that's meaning. Okay. Electrons in the periodic table are arranged by increasing number of the atomic number, so we discussed that already. Number of protons plus the number of neutrons is the atomic number. So if you look here at germanium, 32 is how many protons there are. This is the atomic mass, which is 74, which is the neutrons and the protons put together. So how many protons are there in this element? So there's 32 protons. That goes by the number, where's my mouse again? Goes by the number 32, but its mass is 74. So how much neutrons are there in this nucleus? How would you figure that out, or what do you get? 42. How are we getting 42? What did you guys end up doing? How did you figure out the number of neutrons? Yeah, that's exactly it. So the atomic mass, you take away the number of protons, which is the atomic number, and that tells you how many neutrons. So sometimes there's more, in this case, there's more neutrons in that nucleus than there actually are protons. But it doesn't matter because they're neutral, right? But electrons and protons match. So if there's 32 protons, there's going to be 32 electrons, okay? But that's not the case with neutrons. Atoms are neutral with equal numbers of protons and electrons. Okay, so that's going on that. Of the table, that's where you're doing the symbols. So Jess, you'll just have to catch up after. The presentation will come, you can rewatch it. That's just where you wrote the P plus, the N to the 0, and the E to the negative. Okay? So yeah, so what is it called where, so I'm looking at the blank below the table. Under the list, yeah, I'm going to do that right now. What is the electrical charge of the nucleus? What do you think that's called? What do you guys think that's called? It's not like a magical name. So the nucleus, good, nice, yeah, that could be one. So it's either called an ionic charge, so you can call it as the ionic charge, or you can call it the nuclear charge. Good, nice. And then the number of protons, what was the number of protons called? That's here. Number of protons, what's that called? Yes, atomic number, and has different number of protons than neutrons. And what is that? That is where? What place has protons and neutrons in it? What place is that? No, what place? What place has the protons and neutrons? Yeah, the nucleus. Excellent, good. And then if you flip over, there is a spot for you to label. So I use the image from the titanium. So Magical Merle, if you can just take me off, please. So right there where it shows titanium, it's showing you what each of those mean when you're looking at the periodic table. So the 22 is the atomic number, so that's how many protons there are. The symbol, which is obvious, the name, which is obvious. Atomic mass is going to be the number of protons and neutrons in there. And then the ionic charge is something that we'll discuss a little bit later, but for some of them, it's, some of them they have that showing and some of them they do not. And we'll talk about that a little bit more at a later date, but it's good to know what that actually means. So you guys can fill that onto that second page, and your second page should be finished now because we've gone over everything on that second page. So that should be good there. So I'll just give you guys a few minutes to look at that. What is the blank? I said we're going to do that in a second, Dean. Yeah. Yeah. Okay, so hopefully you guys had a chance to write that in. So we're going to go to the third page now. And Magical Merle, can you put up the periodic table again for me? That'd be fantastic. So what I want you guys to do, we've gone over all this stuff on this page already. So on page 3, it says each element is listed according to its atomic number. Its atomic number. I answered that for you. Each row is called what, guys? What is each row called on the periodic table? What are they called? So rows, remember, are the horizontal ones. Yes, a period. Perfect. And each column, so the next one is each column. There's 2 names for it. So what are they? Group or family? Perfect. Thanks, guys. So that's the next one. So these elements have similar chemical properties, the ones that are going down. Good. Metals. What side are metals on if you consider from the middle? Perfect. They're on the left side. Good. And then it says nonmetals are in the upper what corner? So nonmetals are in the upper right corner. Perfect. So they're way up there. And then we have the ones that kind of go between kind of 3 and 12. Those ones are called transition metals. So we haven't talked about that. So those are ones that are transitioning from metals to nonmetals, like that. Okay. Oh, sorry, I missed the other one. Metalloids are the staircase one. Sorry, I middled that one. Sorry, what metals? So it says nonmetals on the upper right, and it says the metalloids are the ones that form the staircase, right? So that's that one, and then transition metals. Transition, they're making their way from here to here. They transition. Well, you guys tell me. You guys know what this is, okay? So we've gone over this, so you tell me which is the first one. I don't know what one you're looking at. There's a lot of things going on there. Okay, perfect. Good. So, so this is just the basic understanding of the periodic table, looking at what everything means. And if you notice on this periodic table, the ionic charges are showing on almost every one of those ones except for those bottom new ones. So good. Nope, the first one is atomic number, not atomic mass. Atomic number. Yeah. Yeah. Atomic number is the number. So 21 means that's how many protons there are. If you look at 21, it's not its mass. The mass is the number on the bottom. So it doesn't go by that. Okay? Good. So what we're going to do now is I want you guys to go to the very front part of your page. And what we're going to do here is we're going to just practice drawing an atom, okay? And what we're going to do is we're going to draw a carbon atom. Okay, so we're going to draw a carbon atom. And what we need to know is what number on the periodic table is carbon? Does anyone know? Actually, yeah, let's go. So anyone tell me what number carbon is on? Oh, wow, you're so fast, Cassie. That's awesome. Yes, it is number 6. So the 6 represents the atomic number. So if we can go back to the other screen, what does that mean? If it's a 6, so it's a 6, what does that mean? What does that tell us when we go to draw this atom? What does it tell us that we know already? There are 6 protons. So I'm going to create in the center, this is going to be my nucleus, and in the center I'm going to draw 6 protons. And how you do that is you put a plus. Now don't fill it all up with them because what else is also in here? There's also neutrons in here. Okay, so I know there's going to be 6 of those. Now, what is the atomic mass of carbon? What is the atomic mass of carbon, roughly? I don't know if anyone has it in front. If we can maybe pop up the, there we go. Okay, good, thanks, Belle. So it's 12, okay? So atomic mass is both the protons and the neutrons. So if there's 6 protons, how many neutrons are there? If they have to total to 12. If there's 6 here, there are 6 neutrons. So we need to do 6 neutrons in here, okay? So you can just do an N and do 6 N's in here. And it's fine if it's squishy, because that's the whole point. It's supposed to be squishy. Squishy. Yay! Okay, so that is that. The other way you can show it, and I'm going to show it over here, you can also go 6p plus. Because remember, that was how we wrote protons in that other one that we saw. And neutrons, you can go 6 and 0. So this is more visual. This one right here with the n's and the pluses, that's a little bit more of a visual way of showing it. With the 6 plus, that's probably the way you're going to write it more often. But I want to show you guys both of those. So what this means is that it has 6 electrons as well, because the atomic number, how many protons is that, is it's also how many electrons it has. Does anyone know, if you remember, how many electrons are in the first ring that orbits around the nucleus? Does anyone know or remember? Yeah, good job, guys. So I want you guys, and they usually do north, south, east, west is how they draw this. So you're going to have an electron in the north and an electron in the south. Does it absolutely matter? No, it doesn't. But that's normally how it goes. Okay? So we have 2 of the 6. So we're going to have to make another ring and put 4 in that one because we got to make 6. So I'm going to put 1, 2, 3, 4. Okay? And what you would do is you can put a little negative sign into all of these to show that those are the electrons. And then what you would have 6 electrons that are neutral as well. Okay? So this is how you draw a basic atom. You show how many protons and neutrons are in the nucleus, and then you show in the orbits how many electrons there are, and it's always going to match how many protons there are. Okay? And in this second ring, yes, thank you. Good. Thanks, Bella. That was my question. In the second ring, there's going to be a maximum of 8, and then the third ring, a maximum of 8, and then the fourth ring is 18. It can go up from there, and then it goes up from that. Okay? So it goes 2, 8, 8. I won't make you draw any more than those ones, I don't think. So that should be good. Okay, so that was just a little bit of practice of how to draw an atom and knowing how to look at what it actually says on the periodic table and take that information and help you draw that. All right, so the next part of what you're going to do is you're going to get some practice drawing some of those. And we're going to start looking at something called Bohr's diagrams. Okay, so let's go to this slide. There we go. Okay, come on, there we go. Okay. So Bohr-Rutherford diagrams is how we typically draw the atom, and that's kind of basically what we just did. We're going to learn about another one afterwards as well, but this one we're going to look at right now because you can show it both ways, but we're going to show this one first. Okay, so this is your note sheet. So now we're back onto the 3rd page where it says Bohr diagrams. Yeah, perfect, yeah. So what we're doing is we're sort of like, this is all basic review, trying to jog your memory and get it working again, and then we're going to start building on this stuff from there. So, okay. All right, so we're under the Bohr diagram part on your notes. So it says, a Bohr diagram shows the arrangement of the subatomic particles. So that's what it's showing there, okay? So what it does is shows how all those particles, the neutrons, protons, and electrons are arranged. So that's what it's showing with that. And then it says electrons are arranged in what? What are those called? What are those things called outside of the nucleus? What are those called? Subatomic particles, yeah. Yeah, so what are those things called? Not the rings, but thank you. Yes, they're called the shells, yes. So those are they are rings, and that's how I'm going to refer to it because that's what it looks like with the official name. They're shells. Yeah. And we were just talking about the Bohr diagrams. So the first shell has how many electrons in it? Let's go. Let's see those numbers. Punch them, punch them, punch them. There we go, 2. So that first shell has 2. The next one has 8. Yes. And when the outside shell, this one we haven't talked about yet, when that outside shell is full, there's no other shell after it. That last shell, it could be the first shell, it could be the second shell, it could be the third shell. Whatever the valence shell is, thank you, whatever that one is, when it's full, it is called a stable shell. And that's what makes those noble gases special, the ones at the very far right on the periodic table. All of those ones have a full valence shell. Yeah, they're called stable. Yeah, yeah, like a horse stable. You can call it a stable shell, or you can call it, the better name would be, I'm going to type it for you, stable, whoopsies, auklet. So stable auklet would probably be the better terminology for that. Yes, exactly. And when they're stable, they don't have to do that, right? They don't need to join together. They are some of the more reactive ones. So, yeah. Okay. And then the next part after the stable auklet, it is the outer shell. It's called the valence, and some of you guys have been writing that on there. So KDT has it written at the top there from what I can see in your conversations. The valence shell. Valence shell, so that's the outline one. And how the electron is just with an E negative, so valence E negative is usually the next one for that. Okay. Yeah, so then it says these electrons are involved in chemical bonding. When an atom forms a compound, it requires a full valence shell. That's what it wants to do. It wants to be full. So if it doesn't have that, everything wants to be like a noble gas. It wants to be that kind of stable noble gas that has everything going on. Oh, I answered your question wrong, Cassie. Sorry, those are stable. They're not the most reactive, sorry. Those guys are stable. So they're very stable. They have their full valence shell, and everything else wants to achieve that goal. They want to be like them. They're like the cool people on the periodic table. So what everything wants to do is through chemical bonding, they kind of do some sharing of electrons in order to try to make that last one full. And so that's their goal, is try to do that, and they want to achieve a stable low energy state. So that's the last two blanks, stable low. Stable low. Okay, so now we're going to get you guys to do a little bit of practicing of your drawing. And what I'm going to do here is just go through showing you how to do this again, how to draw it. We're going to use this as an example. And then I'm going to give you guys a few minutes to do some practicing of drawing some of the elements on your own. Okay, so you draw the circle, and then what you do on the inside, so this was yes, so on the very back of your page, you're drawing this with me. Yes, thank you. So you're going to draw your nucleus, and yep, Na, perfect. What is Na? Na 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 na, Batman. Yeah, it's sodium, good. So we're drawing the sodium atom right now. And so what we're going to do is we start off with a nucleus. And so what we're going to write in the nucleus, is it number 12 or 11 on the periodic table? If I just look at this, don't look at your periodic table. If you have it, is it number 11 or 12? If I look at what I have up on the screen right now, I can tell it is number 11. Good, because it goes by the proton. So sodium is number 11 on the periodic table. And we put 11p, positive little plus symbol, and 12 neutrons. So what's its atomic mass? If I can see this, what's its atomic mass? Without looking at the periodic table, just looking at the nucleus, it is 23 exactly. You take the protons and neutrons and add those things together. You betcha. So we do that. Then we draw the first circle, and that represents, and we know we have two electrons that to go in there. So what we're going to do is put 2 in there, and then we're going to go 8, and then we're going to do 8 until we keep going until we get to 11 electrons, because it has to match the protons. So 1, 2. So now we filled that first shell. Now we're going to do the next shell. So here's our next shell. And we can go up to 8. Am I going to fill this entire shell, or am I going to be short? What do you guys think? Am I going to fill this shell? Because I can go up to 8 on this one. Am I going to fill it up, or am I going to be short? Yeah, I'm going to be short, not 2 though. I'm going to be short just 1, because I can do 8 on this one. I already have 2 showing, so that's 10, and I need 11. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we have 8 of those bad boys on there. So we have 8 plus 2 is 10. We need 11. So we're actually going to the third one. And if you notice, sodium is actually the third period, which means it has 3 shells. Okay, so that's that one on that one. So we draw one more, And we add one little lonely guy in there. He's all by himself. And one day his goal is to try to help something be stable, and he's going to try to join up, and he's going to be like helpful. He's going to be his one little self, and he's going to try to help some other element out and join up with them that needs one. Okay? So that's what I want you guys to do. So I want you guys to, don't worry about the iron one. Okay. So what I want you to do on your sheet is you guys are going to fill in, oh, I didn't, there it is. This guy, okay? So what I want you to do on this sheet is I want you to pick minimum of, I think I said 5, okay? I want you to pick minimum 5. Don't do, obviously we just did sodium, so don't do sodium. But I want you to pick 5, and I want you to draw what we just did on here, okay? Now, one of the things you can do, instead of trying to get these rings in here, I'm going to show you another way of doing this. I'm just going to draw it up. Let's shift up here. I'm going to draw it up here. I'm not going to put it in here. I'm just going to make something up. So what you can do is you can draw it, and you can put on, like I said, I'm making this up. I'm going to say 100 protons plus, and there is 100, I'm going to just make it even, 100 neutrons. Now, instead of drawing a whole bunch of rings, because you might have to draw 2, 3 rings, like this is 1 ring, 2 rings, 3 rings, 4 rings, right? So that looks like an eye. Instead of drawing that, what you can do is they do something like this. They say this one is going to have 2 electrons negative, and they do a kind of like a pretend ring, like this. And then they do the next one and says, because I have 100, I'm going to go 8 electrons here, and they do this. And then they keep going until you get to, until they get going to that. So with our sodium one, we would have had a 2E negative. We would have had an 8E negative, and then we would have had a 1E negative, right? And then we would have had our nucleus there, okay? So that's another way of drawing it without actually having the ring. So this is just showing kind of part of the ring with how many electrons are in there. So instead of drawing all those circles, okay? So I'm going to give you 5 minutes, and what I want you guys to do is pick 5 of them. Try to do ones we haven't done. And I want you to draw what the Bohr-Rutherford diagram would look like for that element with putting in something like this for the nucleus and then showing that. If you want to do a ring, like if it's only 1 ring, if you want to do the nucleus, you can draw it like that, but if it gets a little bit too complicated, you go outside the box, that's totally fine as well, okay? So I'll give you guys 5 minutes to do that. Yes, so that's what you guys are going to be doing here. So say you pick this one, this one, this one, this one, that one. You pick 5 of them. You're going to draw them in that box. I'm not going to make you do all of these, but I just want you to pick 5 of them. Yep, just from this sheet. Just from, this is what you guys have on your sheet. I want you to pick 5 of these. Okay, so everyone who's ready, you guys can go. So Angelina, what are you confused by? You're going to be drawing what I was doing here. So you're going to look at this. This is its atomic number. That tells you how many protons there are. That's what you put in the middle. So you'd say 9. I'm just going to make it bigger here. You're going to say 9 protons, and then you're going to look at its atomic number, figure out how many neutrons there are, put that in the center of the nucleus, and then you're going to draw the rings. Does that help, Angelina? You have to know you have to look at this number. That number is the atomic number. That tells you how many protons there are. That tells you how many electrons there are. And the first ring has 2 in it, always. The first ring always has 2 in it. The next ring always has 8. So if I'm drawing something like this with 5, I would put 2 here, and I would put only 3 there because I only have to do 5 of them. Okay? Yeah. Good? Okay, perfect. All right, hi guys. Sorry, the timer froze, so we're just going to do that. Not a big deal if you just want you practicing this. It's going to be one of your assignments to do. So just to go over this again, what I'm going to do is show you what it actually is going to look like. So here is an example of what you're like, and this is showing the actual rings, right? You might not have had enough space to do that rings. Okay, you'll have to catch up on that, okay, Jess? So this is showing whatever ones you picked, 19 and 20 are on here, but it's showing how they should have been drawn. So if you look at carbon, carbon is 6. So you have 6 electrons. You have the 4 in the valence shell, and then you got 2 on the inside. And so you should have a 6 plus, and you look at carbon, you go to your periodic table. You should have a periodic table printed off, just so you know, and it makes you help. And it's, carbon, its atomic mass is 12, so that means it has 6 neutrons as well, so I know what to put in the middle of it, okay? So that's just an idea of how to draw these. So I'll just leave this up here for a second, so you guys can just double check the ones that you chose to do. Imagine, Merle, if you can just take me off so they can see 18, please. And then you guys can make sure that you have the right number of shells. So the third row from sodium all the way to argon, those ones should have 3 rings because it's in the third period. And notice the ones in the second period have 2 rings, and the helium and hydrogen, the only ones have 1 ring. Okay? And then if you notice in group or family 1, if you guys notice in group and family 1, there's 1 in the valence shell. Oh, look, there's 1 in the valence shell, and oh, look, there's 1 in the valence shell. So that is a little bit of a hint that a lot of times there's patterns going down the group and the family, okay? So that is what makes these guys super special. So you can see that there is a pattern going through the periods and a pattern in the group or family, however you want to look at that. Okay, so I'm going to show you this next one here. So it's just looking at, just seeing it a little bit differently, and it's showing, again, this one actually shows 19 and 20, and it's just showing you what I just said, is that you can use the table to, without having to do a lot of work, kind of guess. So if I said calcium, if I said calcium, how many shells did it have? You look in its row 4, you say it has 4 shells. You don't have to count, oh, it's number 20, so it's 2 plus 8 is 10, then 8 plus 18, there's going to be 2. So it allows you to do a quick answer without having to do a lot of thinking about it. And then it also tells you, being in group 2 or family 2, it tells you it's going to have 2 electrons in its last shell. So that tells you it has 4 shells, and then that 4th shell, there's only 2 electrons in there. So that's what you can look at when you're looking at calcium. Okay, and then the noble gases are these last guys here, and the noble gases are stable, meaning they have full valence octet shells. They're all full. That's what the noble gases. So they're very stable because they're not missing electron or don't have one extra that they don't need. Okay, so everyone okay with the drawing of that? Let's have some feedback. How are we doing here? So when we're drawing out the shells, we want the number of electrons to be the number of, yes, yeah. So the atomic number is the number of protons. Also, it represents the number of electrons. The atomic mass is protons with neutrons. Yeah, good. Okay. So we're just going to look at, we've already talked about this, a full octet. We talked about this. The only difference is there's an ion. There is an atom and an ion, and they're the same thing in essence. The only difference is an ion is when it's like I said, they're all trying to become stable. They want to be like a noble gas. And how they do that is sometimes they have to give away an electron or more, or they need to get an electron. So let's say in its valence shell, it has 1 there. It wants to get rid of that 1. It's an extra 1, so it wants to join up with another atom and share that 1 so that it can try to be as stable as possible. Then it becomes an ion when it's sharing it or taking or getting extra things. Nope, these are your notes. These are for you guys to study, okay? Yeah, so that's basically what an ion is. It's just when you're referring to how many electrons it has to give away or how many electrons it needs to take in. So that's the difference between that, okay? So if I was to show on here, So I have my nucleus here. And let's say I have the first ring. Whoops, I don't know why I did that. And we have our second ring, and let's say it's number 3. It has one extra electron in that valence shell. It has basically, you can put, it has, what they usually do is they kind of show it with an X or something like that, showing that that's an electron that it wants to give away. So it's going to want to eventually join up with another atom that needs 1 electron. Okay, if another atom needs 5, we might need 5 of these guys to join up so that they become stable. So we're going to get into that a little bit more, so don't worry about that. If it has 4 valence shells, would there be a negative or positive 4 for the ion? The valence shells is not what tells you, it's how many electrons there are in its valence shell. Oh, if there's 4 in its electron shell, it could be plus or minus. It could be plus or minus, yeah. So that's where you'll have that differences. Yeah, it could be both of those. It could give away 4 or it could take 4. It just depends on what it's going to do when it does the chemical change, when it turns into a compound and stuff like that. Okay, so we're going to kind of end there, but I want to go over quite a few things here, and we still have to talk about PE as well. So don't go to Moodle, but I'm going to talk to you guys about some stuff that's on Moodle here. So one of the things that I've given you guys is this one, and I'm going to show you in a little bit bigger form. This one is what I would really like you to print out, plus a few of the other things. So on your Moodle site is going to be this guy, okay? And what this guy is showing, perfect. This here is telling you at the top how many extra electrons it actually has in its valence shell. So this right now is saying it has 1 to give away. This one has 2 to give away. These ones have 3. These ones could be giving away 4 or adding 4 or taking 4. So that's kind of what you're getting at Bell. This one says basically it needs 3 of them. So that means there's 5 in the outside and it needs 3 to make 8. This one means it has 6 in its outside valence shell and it needs 2 more to become stable. This one needs 1, and then these guys are stable. These ones here in the middle, I don't think there's really a way of, you're just going to have to look at the number and kind of figure it out. There's not an easy thing like this to use, so you'll just have to look those ones, try to figure those out. But it's usually going, you can just kind of figure it out by subtracting 8 and 2 and do that from there. So this one is really good because it does show that for you, all right? Or you can print off another one and write this on the top. So that was just my little thing I wanted to show you, okay? The other thing that I want to show you is on the back of, I think it's this worksheet, one of the sheets has this on there, and this is going to be really important later on, so you're going to want to print this off as well. As we are starting to work through some of this, understanding some of these polyatomic ions, we're going to learn about these. This is some things that, so you don't have to memorize them, because I don't want you to memorize it. Yeah, so I don't want you to memorize this, so have this printed off. You can print both sides or print separate pages, and you're going to need to know these as well. Prefixes, we're going to get to that. So this is just a little kind of cheat sheet that I suggest you guys print off, okay? The next thing is this guy here, and this is on Moodle. So remember I mentioned that I had this for you? So this is having pictures with each of the elements. So this would be really cool to print off so that if you get to the spot where you're like, okay, what's the point of that or what is it? This has little pictures. So it's really fun. It's nice and colorful. I like color. So I thought that was pretty cool. So you guys can print that off. Oops. And then this is the song. So it'd be cool for you guys to have that. So it has like a nice little rhythm. And see if you can challenge yourself to get two of the stanzas done, figure it out, like see if you can memorize to do this one and do this one. Up to you, Belle said she had some of it memorized too, so that's kind of cool. Then, oopsies, oh, there it is. Then I have this one, nope, this one. This is really, really cool. It's an interactive periodic table, and so it allows you to click on it and go to that actual part of the element, and it has ability to like see it a little clearer and do a little bit of work with it versus just a stagnant table. So this is really cool, so I'm giving you guys a link to that. And I'm also giving you guys a link to this. So you guys have seen, so I've shown a few pictures here. So carbon, look at the picture there. Titanium, these pictures, somebody, I can't remember the lady's name, she went and did this. She went through every one of the elements and created an amazing image that usually has something to do with what that element is in, and then has some of the information. So titanium is non-allergenic and can be used in body piercings, right? And then the carbon can take the form of charcoal, graphite, or diamond. So really, really cool. And look at her clothes. They look kind of black, like charcoal, graphite kind of stuff. So really kind of neat. Look at them. They're so beautiful. And I put them a lot on these ones as well because I wanted you guys to see that, okay? Another link. There is an actual worksheet to do with this. This is allowing you to do some practice with atoms. So when you go to this site, it's sort of, it's kind of like a gamey sort of thing. And it allows you to practice going, okay, what's the atomic number? Okay, so if I know the atomic number, how many electrons are there, okay? So if the atomic mass is 10 and there's only 4 protons, how many neutrons do I have? So it allows you to interact with it that way and have a little bit of practice of reading what all these numbers mean on the periodic table, okay? So this one is really cool, so you guys need to be doing that one as well, okay? And I'm going to give you guys a quiz next week. Why did I put Thursday? I should say Tuesday. That should be Tuesday. Yeah, your quiz is on Tuesday. My bad. Let's make that Tuesday. I don't know why I did that. Okay. So your quiz is going to be on Tuesday, and I only want it on the basic understanding of the periodic table. So like I said, I'm not going to make you memorize where magnesium is on the table, what its atomic mass is, atomic number. What I am going to ask you is, do you understand what the atomic number stands for? Do you understand how they get atomic mass? Okay, so do you understand that the period is the one that goes horizontal and group and family go this way, and what the valence shell is and what the shells are and how many electrons? So just that basic understanding of that, okay, which should be okay because most of you guys, this is kind of review-ish stuff for you, all right? So yeah, this one, I found a lot of these. I don't know how many questions there are, Belle, sorry. You must be made of copper and tellurium because you are QTE, cute. So that's what the symbols are for those two elements. So yeah. Okay, so here is the plan for what you need to do. There are things I want you to look at and possibly print off if you want. The graphic elements images, so that shows you some of the really cool pictures that were made from them. An interactive periodic table. Go and check it out. If you don't like it, don't need it, that's fine, but just go and at least see what it is. Song lyrics, and then there's a PT stands for periodic table, what it's used for, so that's the really colorful pictures of, like, if it has copper, it shows a picture of the copper wiring or something. And then the periodic table with those key notes that I showed you that we're going to use later, like polyatomic ions and all that stuff. There's the interactive atom site, and there's a little worksheet to go along with that. You have 2 worksheets that you're going to have to do, and I'm going to show you those in a second. A quiz next class, and then I'm going to talk about PE. For the first worksheet, you go to the one site. It's an interactive atom site, and then you just fill it in as you're going from that. It's pretty self-explanatory with that. Okay, so what I'm going to do is show you the 2 sheets I want you to do. So the one sheet I want you to do is this one, and this is going to help you for the quiz. So you're going to look up each one of these elements, and you'll see when you get to the site, Belle, because right below it is going to say what needs to be handed in. So it says boron, and so it says atomic number. So basically it's just having you practice reading the periodic table and understanding what it says. So what's the atomic number, its mass, number of protons, neutrons, electrons, what period it's in, how many shells are there, what group it's in, how many how many electrons are in its valence shell, and what's its charge. So its charge is this stuff here. So is it a positive 3, meaning it has 3 to give away, or does it need 2? So it'll be a negative 2. So that's what that means. Okay, so you would be writing here, let's say it has, in its outer ring, it has 2 electrons. It has 2 electrons in its valence ring. That means it has an extra 2, has a positive charge. Let's say it has 7, I'm making this up. Let's say it has 7 in its valence ring. That means it is short 1. It needs one of them to try to get to 8. Okay, so that's what I want you guys to do on this one, and that's one of them that has to get handed in. And then I want you to do this one. So this is practicing working on the Bohr diagram and looking at the ionic charges. So you're going to fill in the symbol, you're going to fill in the diagram, so you're going to do the nucleus, and again you can do that method I showed you. Sorry, my pen doesn't work really well in here. Like that. Then you can do the diagram where, let's say, so this guy has 2, sorry, I'm not using my normal thing that I use and it's not as easy to write with. So I have this one, and let's say the ionic charge is this. So I would have this guy is, I have an extra one on here. So you just indicate that it's an extra one. So it's going to be ionic charge of +1 because it has 1 extra in its outer shell. So almost like same as the other worksheet, except here I want you to be drawing what it looks like with the charges. Okay? So those are the 2 things I want you guys to hand in. So I'm going to show you the site. So under the chemistry site, I'm making my PowerPoint available for you guys. So what I just did with you guys is going to be available if you need to go back and look at it. So here, whoops, what did I do there? Are these showing? Okay, so, I got to refresh this, that's why. Sorry, I already did this, but it didn't. There we go. So I'm giving you guys a link. So this is the elements one that I didn't get you guys to watch, but you can. So where they get their names from. It's optional, but you can find it interesting. The periodic table, so this is the interactive one. So this is the link to that. So go check that one out. This one is elements. Has all those pretty pictures, so you can print that on off if you want. This one is the periodic table. You need to print this one off. So that's the one that has on the back of it the polyatomic ions is also the one that has that little crib notes on the top that I wrote. This one is the link to seeing all those cool graphics that lady did with all of the elements, which is really nice. Periodic table, this one isn't actually an extra one. It just shows what those rings look like. So it's part of what I did in the PowerPoint. This is a link to the site for playing the game with the atoms and giving you some practice on atomic number and atomic mass and doing all that sort of thing. And this is the worksheet to do with that. And then here are the 2 things that I want you guys to hand in. So this is the one worksheet, and then this is the hand-in. Here's the other worksheet, and here's the hand-in. They're due February 6th, and please remember you have your quiz as well. Okay? Don't go. We're going to talk about PE. But does anybody have any kind of questions on anything with that? How are we doing? Yep, Dean, you'll just have to wait, okay? We'll do it at the end of class here in a second, okay? All right, so everyone's good? So there's a lot of just stuff to go and look at, stuff you can possibly print off, stuff you don't have to, some you should and will and have to. And then there's some couple things to do, and then just some neat things to look at, so that's good. Okay, so what I want to do is just talk about PE. So I'm going to go to the site, here we go. And I'm going to show you, no, there it is it here? There it is. So PE is you have to have PE 10. We're calling it an elective, but it's non-elective. It isn't a required thing that you have to do. It is all you guys. So there's not going to be like a PE class or anything like that. It is all up to you. What I have done on the site, so I'm just going to bounce over to the site. What I have done, there's 4 sections, and at each section I'm saying, here's your goal to have this section done by. You could have this all done by March 2nd. If you want to go and finish this entire thing, except for a certain thing you can't, you can do all the work and everything, by all means you can. But trying to keep this balanced and know that you have other stuff to do, what I've done is sort of found and chunked it into 4s. So, sorry, 1 second. Okay. Quick question, go ahead, Jocelyn. I'm not done talking about PE, but what's your quick question? Okay, I'll go back to that in a second. Yeah, Jocelyn, I'll answer that in a second. I'm just going to stay talking about PE. All right, so for example, this first unit has Friday, March 2nd. Your goal is to have this done by that date. Okay, so you go through the section, there's stuff to do. Some of the stuff won't open up until you finish the thing prior to that, so you can't just pick and choose what you want to do when you want to do it. So then you go to the next unit, and then I would think the goal for that one would be April 13th, knowing there is spring break in there as well. So anyways, there's 4 units that you can do. On the site, at the beginning, the outline is there for you to look at. I'm going to talk about that in a second. Learning outcomes. This is talking about logging in your hours, and you have to do this first, and then you do, there's a little, it's not really a quiz. It's like basically saying, did you watch this? Answer a couple questions is really what it is. And then it has, you can't do this until you've done the other 2. So that's what this restricted stuff means. So in order for this thing to open up, I have to have the other 2 things finished. And then you can start logging in your hours. So I'm going to go back to that. You guys have to have 80 hours of activity from now until the end of this semester. And it has to be, each time that you do it, it has to be 3 different activities that you're doing that. You can't just say swimming 80 hours for that whole entire semester. It has to be some different activities in there. And you can't have more than 30 in one activity. So you're going to have to make sure that if you're only doing one thing, you're going to have to diversify and try to do some other things with that, okay? Each unit is looking for 20 hours. So it's almost like every month you're looking at trying to get 20 hours of activity. And I'm saying month like this because it's not literally necessarily the month, but it's roughly like that. So each unit you need to get 20 hours in. 20 times 4 is 80 hours. So that's how that's been done. So you're going to have to come up with a prediction of what you think you're going to do, trying to get those 20 hours. You're going to, at the end of the unit, reflect on what's happening on that, and then there's some activities you can do with that, okay? Each week you can only do a maximum of 15 hours of activity, so you can't just do everything in one week and get it done, okay? So what they're trying to say is maximum of 10 weekly spots. The workouts minimum 2 hours per week, kind of looking at it that way. And then this is talking about basically the big ideas that have to do with PE. Okay, so that is the PE stuff. Even if you have exceeded 30 hours, yeah, you can just, log it in, definitely. That's not a big deal, but there is a minimum you have to get. If you go well over that, that's fine, but that doesn't mean that that replaces what you do in the second unit. So let's say I did 500 hours in like my first 2 weeks. That doesn't mean I get to do nothing for the rest of the semester. That just means I had an exceptional week, right? And then I have to make sure I'm doing activity every single week, and then I have to get 20 for each one, okay? So yeah, and you have to keep track of that. Yeah, so that's where this recording log is. So let's look at the healthy living just a little bit here. So there's something about goal setting, super easy. You guys have to do that, and then do a little activity, quizzy, not a quiz, like it says quiz, but it's just kind of answering questions from what you read. And then you have to do something with a local community and do some work there. And then it has just a whole bunch of activities here. And then you come down, so then it says preparing for your 20 hours of activity. So this is what you need to start looking at, and then start going into your activity logs and start recording your activity. And then you have another activity log, and it gives you an activity log. It gives you, 10 of them. So it's basically saying there's roughly 10 weeks in this unit every week, kind of putting that in there. It's, or 10 times, yeah, it's, you know what, I'm not even clear on that myself. So this is just showing every time you log in, every time you do some activity, it's just keeping note of that and trying to get to your 20 in this unit is really what that is, okay? So like I said, a lot of this stuff is restricted until you actually do this. And then each unit, so I'm going to fast zip through this, each unit has those logs in it. So if you notice this unit, physical literacy, is very small. There's only a couple things to do. And then it starts your activity logs. So your activity logs, keep track of those, and you can keep track of them on a piece of paper and then add them in afterwards. Kind of, it's up to you, but yeah. you need to have different activities. So not every week, but you just have to, in that period of time, it has to be 3 different ones. Yeah, so it's not overly stressful. Don't stress about it too much, but in that period of 20 hours, there needs to be 3 of them. They're different. So not necessarily each week, but for that period of 20 of them. Okay? Yeah, so I won't be... No, you can do, no, you have to, each unit you do 3 different ones. So I could do volleyball, basketball, and baseball. And then my next unit, I can do volleyball, baseball, and basketball, but they're 3 different in each. Doesn't mean each unit you have to have 12 different ones. 3 and 3 and 3 and 3. It doesn't mean 12 different ones for each time. It just means in that chunk of 20 hours, they have to be 3 different activities. The next one, in that chunk of 20 hours, 3 different activities. Doesn't mean different from each unit. Yeah, okay. All right, so PE, I won't be bothering you with the PE. You guys will just need to keep track of that, do that. There's, like I said, that first unit has a few more things to do, but the second unit is quite manageable in terms of what you have to do. The second unit, you just have to really keep track of your hours and everything, okay? All right, so any questions on PE? Jocelyn and Dean, you can stay back for a sec, but any questions on PE or any of the science with that? Okay, awesome. All right, so classes on Tuesday, Thursday next week. Make sure you're looking at the homeroom calendar for that, so that you always knowing, always knowing when the classes are, okay? So I'll get anybody that needs to stay back to have me answer a question, I can do that for you. Yes, you can go as fast as you can, but at the same time, you have to do certain in a chunk. Like I said, the hours is the only thing you can't speed through. The hours have to be legitimately through the entire semester, but all the other stuff, you could go through it as fast as you can. Yeah. All right, so I'll say goodbye to you guys. I'm going to stay here and answer some questions just really quickly. But the rest of you guys, you're welcome to go. Have a good one. Have a good weekend. And have fun doing some science. Okay, bye you guys. Okay, so Jocelyn, what was your question? Sorry, it's all gone now. I'm going to have to get you to tell me what that is again. And then I see Alexa sent me a message. Yeah, I can work on that with you, Alexis, too. Okay. All right. How do you calculate? Okay, yes. So I'm going to show you this guy here. So this guy is going to be very, very helpful for you because it's going to show you the charges. So this means, this guy right here, that means that it has 2 electrons in its valence shell, meaning that it has 2 extra to give. So it has a positive 2. It has 2 more than it actually needs. So it would want to give those to something else. This guy, for example, is missing 2. So he has 6. He has 6 on his outside valence shell, and he needs 2 more to be stable, 2 more to make that 8. So what would be a good match? Some of these guys would be a good match because he needs 2 and they have 2. I'm not saying that's the only match there is, but that would be an example of, hey, I got 2 to give. Hey, I need 2. Yay! You know, like that kind of thing. So that's what this shows. It's however many is in their last shell. If they have 1, 2, or 3 extra, that means they have too many. And if they have, so this guy has 7, 6, 5. So those guys have 5, 6, or 7 in their outer shell. So they're needing either 1, they're needing 2, or they're needing 3. This guy is the only one that's different because it has 4. So it could need 4, or it could give away 4 because it's right in the middle of needing and giving. So that's the only one that is plus or minus. Okay? So hope that clears that up for you, Jocelyn. Good. Okay. Alexis, was that towards a question? Dean, do you need a private talk, Dean, or can you ask me something here? Okay, that sounds good, Dean. That kind of helped. Okay, so do you need anything else there? Okay, good, good, good. Angelina, Kaylin, what can I help you guys with? Just waiting to see what you guys need help with, if anything. Okay, perfect. Okay, thanks, Kaylin. I think Dean wants a private thing here, so I might just go off of live and just do Blackboard with him. Sorry, 1 second. Okay. Okay, good. Okay. So yes, if you can just stop the recording there, and I'm going to stay on Blackboard here just quickly with you, Dean.